Hello everyone. Welcome to another day of daily LeetCode live streams coming to you on Saturday night, doing a little bit of a different thing. I've been sort of off, doing the streams at different times. Sometimes I do them in the morning, other times I do them at night. Normally on the weekends I just do it depending on how I see fit. And today just had a lot of other things to take care of, around the house and some other errands I wanted to run. So just wanted to make sure I took care of those things first. Now I have some time to get into LeetCode, and let's just jump right into it. There's some questions here that I actually did on yesterday's video, but it was on a different session because the different session I have on LeetCode is actually the one I'm doing for my Explore Card video series. If you haven't happened to seen those already, you can find them on my YouTube channel. And I've also updated my website actually to include some of these playlists now. So normally what I do is I'll add some new text to these sections up here. Now you can see that it says, if you're looking for more tailored videos of LeetCode questions based on the Explore cards, click on one of the playlists below. And like this one, for example, is LeetCode Beginner's Guide, and it takes you to the video series I'm doing for the LeetCode Beginner's Guide Explore card from LeetCode. So if that's something you're interested in, make sure to subscribe, watch all the videos. They're going to help you get to the next level in your career and your next level of data structures and algorithms. All right, sweet. So without further ado, let's just go straight into the next question. So I believe the one we need to tackle today is called first unique character in string. All right, so given a string S, find the first non-repeating character in it and return its index. So when I think of this, the first thing that comes to mind is frequency, right? We want to find the first character that does not repeat. And if we think about this, like, I guess there's maybe a couple of different ways that we can do it. Like if we were to sort the string, then we would just find the one that is not next to a duplicate of itself. However, I just realized that the sorting will put things out of order, right? So let's say like, is there anything before L? Like C doesn't repeat, but C is not the answer. And that would be the first thing if we sorted it, right? But I guess in that case, would it just be the same index 0? I'm not sure if, I feel like that could potentially mess up the ordering, so it might not be something that we want. So I came down here to the constraints because I'm seeing that this only requires lowercase English letters. So I think this will be another great example of us being able to use like a fixed size array that represents our alphabet or the lowercase letters, and that will be the array that represents our frequency. So I'll go ahead and I'll start off with creating a frequency array here. So we'll set this equal to 26 so we can get all the characters from 0 to 25 since we're doing it 0 indexed, and we'll fill it up with 0. Then what I can do is I can do const C, where C stands for car. So for const C of S, what I can do is I can get my index c.carcode at 0 minus 97. This is a very common trick. This is probably one of the most common things, or most frequent, no pun intended, things that I've done on all of these streams, which is I take a character and I get its character code, the decimal value of it in the ASCII table, and then I subtract 97 so I can normalize characters, and that way they can fit inside of this frequency array. And that means that lowercase letters like A map to 0, B maps to 1, C maps to 2, so on and so forth. So I can take the index here, and then inside of my frequency array, I can index at that index, and I can increase the frequency plus 1, right? And if we go through that, now all we need to do is we can go through the input string again for const C of S. We'll do the same thing where we take the index, and if frequency of index, let's see, the first non-repeating character, if frequency of index equals 0, well, it wants us to return the index. So because I need to get the index and not the actual character, let me actually go back here and do a normal for loop. So I'll do I less than s dot length, I plus plus. The index will now be, instead of C, we'll do s of I. And then if frequency at index equals 0, we can return I, else we can return -1. So let's go ahead and run that, at least for our first example here. So -1 and 0, let's go ahead and investigate why that happened. So for const C of S, we're going through each one of these. We get the index of C.carcode at 0 minus 97, and we do the frequency of index plus or equals 1, so we should only ever have 1 here. And now we say let I equals 0, I less than S, dot length I plus plus, const index is s of I dot car code, so it should still be L minus 97 if the frequency at index is equal to 1, not 0, right? We want to go ahead and return that I. So we got 0 and 0. Let's now use all of our different example test cases. Let's run this and see what we get. We got 0, 2, and -1. So let me go ahead and run this. Cool, we're off to a great start. 92.97 for our time complexity and 83.42 for our space complexity. Let's go ahead and give ourselves just a quick analysis here. So if we think about the time complexity, right here, this is going through, like both of these for loops are going through S. So it's O of n plus O of n, which just normalizes to O of n. So it's a linear time algorithm. And the space complexity here is constant, right? Had we used, now, and I think the reason, like if I did something like this and I use an object literal, the object literal is being created in heap memory. So it's more difficult for the compiler, the program, to be able to optimize for this. But by creating something like a fixed size array, that's just a contiguous block of memory that we're already asking for upfront once. And it doesn't matter the size of this input, since it's all lowercase letters, this will always be size of 26, which makes it for a constant space algorithm, which is nice. I feel like O of n for either of time or space and constant for either time of space is a great combination. So let's go ahead to the solution. Let's see what it wants to say. So a linear time solution. All right, you have to check the whole string anyway and save it in a hash map. Go to the string a second time, check if a character is unique or not. So that's pretty cool. Let's see what discussions have to say, because discussions often offer us a little more cleverness, I guess. Get the first character that has a frequency of 1. So this is very cool. Yeah, this is very cool. Pretty much exactly what we came up with. So I'm glad that it's in line with our initial solution. So I'm very happy with this question. I really like this question. Let me go ahead and like it. I think this is something that I made a Reddit post earlier today that went well, because I just talked about what I have learned during my time of doing this. And I realized that there's a lot of, oh nice, hey, Fabio Leonam, thank you so much for following me. Really appreciate the follow. Make sure to also subscribe on the YouTube too if you're not already on the YouTube channel, because I have a lot more content on the YouTube that you all don't get to see on the Twitch. So if you want more content, like some front-end stuff and some other content related to LeetCode Explore cards, you can also follow me on my YouTube channel. So this is a pattern, like I was saying earlier. I was mentioning how there are definitely transferable skills from easy questions to medium questions, and I think this is one of them. This is such a popular pattern, you know, like just literally getting a frequency, going through some input, and then just going at it like that, right? Like you keep track of something depending on your input, and then you loop through it again, and you get something from that frequency array that you just filled up, and then you get your answer like that. So that's pretty neat. This is one of the things that I feel like really goes well with medium style questions. Yo, what's up, Dennis? Oh, the var thing. This is actually what LeetCode does. Like I don't actually use var myself. Like LeetCode just sets it up this way, and I'll prove it to you by going to like this next one right here. Yeah, you can see like LeetCode is using var on its own. Yeah, normally like I wouldn't use var myself, but I'm guessing they're doing this in case you're like, I don't know, on like an old browser perhaps, or yeah, a very old browser, or maybe whatever, like maybe they don't have the right bundler to be able to bundle like newer code. I think this is just the most compatible way of doing it. Yeah, no, if it was me, I would probably just use. Oh, that's so cool. Hey, Fab. You gain some more value from the YouTube channel. I definitely, well, I guess this only has my live streams, right? There's other stuff I do that aren't live streams that you can only see on the YouTube channel. So yeah, really appreciate that. Thank you so much. All right, well, anyway, this is going to be our next one. So let's just go ahead to the next one. Count special quadruplets. Given a zero index integer array nums, return the number of distinct quadruplets such that nums of A plus nums of B plus nums of C equals nums D, and A is less than B, C, D. So really we just always want to find, yeah, I think like when I see a question like this, the first thing I think of is brute force. There might be a better way of doing this. I think, you know, maybe if we sort it, like definitely I would want to sort it, and then I would also want to do a brute force solution. 0, 1, 2, 3, 0, 1, 3, 4. I mean, there might be a way that we can do it with like sliding window and being very surgical with our pointers and how we move them. But I also feel like maybe that's a little bit of overkill, because there was a question like this on page 1 of LeetCode Easies that it took me a while to get to it. And when I budged and looked at discussions, and like the most voted answer was a triple nested for loop. And I'm like, okay, that's something that I struggle with sometimes. Like, so it's like beginner's luck, right? When you're new to LeetCode, you're willing to take more risks and just go for whatever you think is right. But then the better you get, you second guess yourself more, because you just always think there's like a more optimal way of doing something when maybe the answer that you're thinking of is already optimal. I don't know. Does anyone else feel that way? Like you'll just be doing LeetCode and it's like, man, I don't want to answer it this way because I know there's something better. But like maybe you already have the best answer, but you're just not trying it because you're like nervous or something. I don't know. Maybe that's just me that happens too. But let me go ahead and try that out. So what I want to do is say sorted. I'll sort this input array here in ascending order. And really what I'm going to do is just go for exactly what they're telling me. So it says the number of quadruplets. So let's say quads equals 0. We'll set for let a equals 0, a less than nums.length, a plus plus. For let b equals a plus 1, b less than nums.length, b plus plus. For let c equals b plus 1, c less than nums.length, c plus plus. And now it wants us to say for let c, and then it also wants d. Do we even have to go one step further? Yeah, I guess so, right? Because we need to get the fourth number. So I'm just gonna go for it, and it's gonna look real ugly, but d less than nums.length, d plus plus. I mean, this is for loop hell, right? Let's just go for it. So now we can say if we just need to compare all of them now, and essentially d needs to be greater than c. So I'm gonna make this big if right here. If nums of d is greater than nums of c, and nums of c is greater than nums of b, and nums of b is greater than nums of a, and nums of a plus nums of b plus nums of c equals nums of d, here we'll just say quads plus plus, right? Because saying that a is less than b is the same as saying that b is greater than a. So I'm just saying that d needs to be greater than c, c needs to be greater than b, b needs to be greater than a, and a plus b plus c needs to equal d, and then that's just quads plus plus. So can we just return quads here? Let's see what this gives us. 1 and 1. I would love, oh wait, I'm not even going through sorted here. So let's actually, yeah. I sorted it and I'm not even using it. So I wish there was there's a keyboard binding in Visual Studio that lets you select multiple of the same word. That would be really nice here. 1, 0, and 0. So already something's wrong here, right? So for let a equals 0, a less than sorted dot length, b equals a plus 1, b less than sorted dot length, c equals b plus 1, b equals a plus 1, c equals b plus 1, d equals c plus 1, d less than sorted dot length, d plus plus. Now here there are 4 quadruplets that satisfy the requirement. If sorted d is 1 plus 1 plus 1 equals 3. Oh, wait a second though. Oh, Oh, it's only that, not the number itself, the index. Okay. It's the index, so we don't need sorted here. So this is C. This should be C. This should be B. This should be B. This should be A. And then we should still be able to leave that bottom piece intact. 1, 0, and 4. 1, 0, and 4. All right. Let's click on that submit button. Let's see. 28, 8, 49. So we got 3, expected 1. Sorted A plus sorted B plus sorted C equals D. And let's see something here. 0 plus 1 plus 2 plus 3. 1 plus 1 plus 1 is equal to 3. Oh, we can reuse? Wait, am I looking at this right? Oh, 1 plus 1 plus 1 is equal to 3. 1 plus 1 plus 3 is equal to 5. Okay. 1 plus 1 plus 3 is equal to 5. 1 plus 1 plus 3 is equal to 5. So what happened here? Oh, nope, nope, nope. Did not want to look at that. Let's see if we can sort this ourselves and see if that changes anything. Because I just figured, I mean, do they not want us to sort it? Is the point of it not to be sorted? 1, 2, 3, 6, 3, 3, 6, 4, 5. Like if we're like, could sorting it mess it up? I don't think so, unless they want the index. I guess because we're looking for the index. The indices could be different if we're sorting them, right? Maybe they want the indices to be a specific index that's not sorted. I mean, we can try to see this. Like let's put this in our input, and we should get 1 for this one if we don't sort it. So let's go back to how we had it before. Although we saw that this was also wrong when we didn't use sorted, right? Because that's why, actually, no, wait. I don't think that's what made the difference. I think it's because before we were comparing the values instead of the indices. So let's just see for fun what this gives us. We got 1, 0, 4, 1. Okay. So now our test case works when we're not sorting it. So maybe it was an issue with that. Give me 1 second because I hear my dog crying. So I'm going to see if my girlfriend can take him out. Normally, if any of you guys have dogs out there, you know that I don't have any kids yet, but I can only imagine it's like having a kid where you cannot just run to them when they're crying. You have to sort of give them time to relax because you don't want the crying to be the signal, you know, that they cry and they get whatever they want. So, you know, you kind of have to let them simmer. Anyway, click that submit button. Okay, so it looked like we weren't supposed to sort it. And I think, thinking about it now, because they're saying that the indices matter, if we sort it, it might throw this condition off, right? So I'm going to remove the sorting altogether. That should improve our runtime a little bit since we're no longer depending on the sorting. Although it's still going to be, the bottleneck is definitely this. But check out, I mean, we're getting 88, right? So I almost feel like the intent of the question was for us to have a quad nested for loop. 37.31. Now it's interesting that one of the next challenges is foursome because we'll check out the discussions in a section, but this is going to be n to the power of 4, right? There might be something that we can do to make this n to the power of 3. Let's go ahead and let's look at this for a second. A plus B plus C. A plus B plus C, we have the C, and then the D one we'll still need to, we still need to go through the remainder of our array. Give me 1 second, my dog is really going at it, so I'll be right back. All right, we're back. Everything's good. Okay, sweet. So I want to look at the discussion section for this. It's going to be very interesting. O(n)(3) space. Oh, time. Excuse me. Oh, okay, I see O(n). Okay, yeah, because they say foursome. So with twosome, what is it that we need to know? Yeah, see, this one's a really great question, because if the solution is something that's closer to twosome, then it definitely makes it. When you say quick, you mean like the like I got to the answer fast, you mean? The thing is, like, you might see it that way, but it's not. I don't even think. I mean, this is like brute force, because now that we're looking at this, C plus D, because with A, we're taking. Yeah, I think they. Oh, yeah. No, he didn't go out. It's just that I wanted to make sure he wasn't crying for something else. My girlfriend's taking him out now. I just wanted to see like what the actual issue was, and I think there was like a toy of his underneath the sofa or something. So she was gonna take care of it once he stopped crying. Okay, so should we? Let's see. Real O(n)² solution. New hash map. Count put nums.length minus 1 minus nums length minus 2 1. Okay, this is. I mean, I want to like give me an explanation. Okay, if fret count nums_i plus nums_j plus nums_k. Okay, so the constraints are very small, so we can just use for loops and find quadruplets. We can use a hash map to store the frequency of numbers, and if we go in reverse order, we'll be able to use the sums that we already saw. We can use a hash map to store the frequency of numbers. Reverse.nums begin, nums end. Frac of nums of 0 plus plus for let int I less than n minus 2. This just doesn't make any sense to me. Store and use the sums that we've already seen. Unordered map frac. Rest plus or equals frac of nums_i plus nums_j plus nums_k. Frac of nums of I plus plus. Okay. Since this question has a very small value range, even the brute force solution passes. This O3 version does essentially the same thing as the first solution, keeping track of A, B, and C. However, by going backwards, we do not need an additional for loop to keep track of D. Instead, each time we see a new number, we increment that number's count in our seen already dictionary. By going backwards, we guarantee that D comes after A, B, and C, and for each combination of A, B, and C, we simply check the dictionary to see if we already have seen their sum before. Possible sum equals nums of A, okay, because we're going backwards. If possible sum in seen already. And this is happening. Yo, MMD, what's up, man? Seen already, nums of A plus or equals 1. Essentially the same as the previous solution, but taken to its next logical step, we go backwards again, but this time we have our numbers in groups of 2. For example, say we have the values 1, 2, 3, 6. The third for loop is responsible for C and D. A plays a role for both C and A, whereas the second for loop is responsible for A and B for each pair. Wasn't able to understand the O(n)² solution. How can variable A be used for both A and C? Yeah, it's hard to just like read this and immediately understand what they're doing. I guess I feel like the O of n to the 3 makes more sense, but this seen already nums of A plus or equals 1. And I guess that's our D. Ah, okay, seen already. Okay, your nums of A acts as your D variable. And then B and C, A, B, and C. For I in range m-1, -1, -1. I fixed my code. Oh, nice, man. Yeah, sorry. I've been very busy with the weekend and things like this. It's just sometimes hard to like get around to just like looking at a lot of code, and so I'm really sorry, man. But I'm glad you were able to fix it. Possible sum in scene already, count plus or equal scene already. Yeah, so it looks like what they're doing is they're taking, yeah, so I guess by going backwards, just like they say, the D, you can always ensure that the D comes after A, B, and C. You can keep track of the numbers that you're seeing, and then all you do is you check if A plus B plus C exists in your hash table, and then you can just return that. I think this is a nice improvement. This one seems a little bit strange to me, but that's pretty cool. Let's go to the next one. Minimum changes to make an alternating binary string. You're given a string S consisting only of the characters 0 and 1. In one operation, you can change any 0 to 1 or vice versa. The string is called alternating if no two adjacent characters are equal. For example, the string 010 is alternating while the string 0100 is not. Return the minimum number of operations needed to make S alternating. I smell dynamic programming. If you change the last character to 1, S will be 010, which is alternating. I want to try something that I haven't, well, because I have heard that like breadth first search is like the way to find a minimum amount of something or a minimum path. So let me go to Excalidraw. What I want to do, so 0, we have 010 here. Imagine we had like a different path that we can take for each one of these. Now, do we just try to change all, like if we, let me think about this. If no two adjacent strings are the same. So let's imagine here we had 4 different paths that we can go down. So I'm going to draw, well, I'll just draw multiple arrows. So you have like one path, you have another path, you have another path, you have another path. And each one of these paths corresponds to like here. So I'm actually just going to make this a little bit smaller. So then here, let's see. Let me just, so here it would be 000. Here we would change 0110, right? 0110, and here we would only alternate the last one, 010. This would actually be, this would be the alternating string, right? Like this would be good for us already. You need 2 operations to reach 0101. So I want to see, like, we got that first example there. Let's see this second example. Now, what happens if we do the same thing? And how far do we go? So I'm going to copy this one. This one will become what? Like 0100. Then we'd have 1000, right? That's what that will become. This would become 1110. And then from the input, this would be 101. Now, when we get to here, 0101. Oh, okay, I see. This one, 01 would be if we modify, let's say each one of these paths has, each one of these nodes has 4 different directions it could go in, right? This one, if we changed it, would end up being 0101, right? That would be like how we got there. This is sort of like the graph to think about. If we have this input at every index, we're just changing 1 every single time. But now, like, my question is like, how do we know that this is the right path to explore? Like, would I have to generate the entire tree? And how do I know that how do I know to stop? Like, why would I not continue going down this path for like potentially an infinite like downward path, right? How would I know when to stop? I feel like this is dynamic programming, and I know that normally when I think of that, I think like top down or bottom up programming. I think of things like memoization. And the reason I decided to draw this sort of graph here is because when I was thinking about doing like Fibonacci using memoization, you can explain it by drawing out a tree like this and showing how you can use cached results. That's why I decided to draw a graph like this, because it kind of helps me see the evolution of all the different, I guess, permutations of this. But now it's up to us to decide, okay, how do we start changing this, and which one do we pick? Because ideally I wouldn't need to pick, I mean, yeah, it would be the shortest path, right? The shortest path to an alternating string. Yeah, because really, if we look at this, I can keep going down all these different paths, right? I can create like 4 more over here, and for fun, like for the sake of illustration, let's go ahead and do that. So copy that one here, copy that one here, copy that one here, copy this one there. This one will be what? 1100, 1100. This would be 0000. Let's move that. This would be 0110, 0110, and then 0. Oh, well, this will also be 0101. So if we think about the shortest path to an alternating string. But now, is this overkill though? Is this too much? Am I thinking too much? You can change any 0 to 1 or vice versa. The string is called alternating if no 2 adjacent characters are equal. I feel like I'm gonna need to know, can we do this with like minimum changes to make alternating binary string? I also don't want to be like greedy per se. Like I just get the first one and I see the second one is not equal to the previous one, so I change it and that's 1. This one's not equal, so I change it, that's 0. Well, then that's gonna give me 3, so greedy doesn't work. This right here is for sure a pattern that I'm not good with, because I'm gonna see a related topic, but okay, string, not even dynamic programming. That just makes it like, that actually makes it even worse, because I was thinking that it's something much more complex, but apparently I can solve it with just strings. Minimum changes to make an alternating binary string. And the only related topic is a string, not even like monotonic stack or just a stack or dynamic programming, array. It's just string. What if we actually, wait, what if we did do a stack though? Like if I did 111, let me actually go back here, 1111. If I pop 1, I say, okay, that's fine. I pop another one, it's not equal to the previous one, so I change it. Okay, 0. Then I pop 1, that's fine. I pop another one. Okay. 0, that's cool. 1, that's different. 0, that's different. 0, not equal to the previous one, so we change it. Wait, is it just that? Is it just that? So perhaps in other languages, we'd be able to change the value of that string just by doing something like s of 1 is equal to 1 or 0. But JavaScript strings are immutable. So we're going to have to at least make this into an array. So if I did const copy is equal to s, which this should give me what I need. let me go to console. We had const s equals const copy equals s copy. That gives us what we need. Okay. So if we did let min equals 0, for let I equals 0, I less than copy dot length, I plus plus. Well, I guess we should just start at 1, right? If copy of I minus 1 is not equal to I, then we change it to the opposite. So we say copy of I equals copy of I minus 1 is equal to 0. And we say 1 or 0. And we say min plus plus. Could it just be that? 2 and 1. Okay. 0, 1, 0, 1. We start at 1. Oh no, wait, that's fine. We only want to do it if they're the same, right? If copy of I minus 1 equals, no, that I think that's better. 1 and 1. 1, 0, 3, 1, 0, and 2. Oh man. We got 3 and it was supposed to be a 2. Start at 1. These are the same, and it's a 1, so we change it to 0. Okay. Min plus plus. Then we come to the next one. These are not the same, so we don't do anything. Then we come to the next one. These are the same. So there must be something here that I'm not. Copy of I equals copy of I is equal to 0. Make it a 1, else copy of I. So what are we doing for let I equals 1, I less than copy dot length? So we get 1, 1, 1. We're doing I equals 1. If copy of I minus 1 equals copy of I, then we say copy of I is equal to, if copy of I minus 1 is equal to 0, we set it to 1, else we set it to 0, and we increase min plus plus. Now I say if copy of I minus 1 is equal to copy of I, which it's not, we go to the next one, right? So that should only give me 2. So am I not changing this the right way? Oh, wait a second. This should be copy of I equals. I shouldn't be doing equality. And we also shouldn't have this floating 1, 1, 0, 1 here. But let's see if we got the right answer here. 2 and 2, okay. Let's submit this. Ah, okay. I was excited for a second. I thought that maybe could have been it. But it probably is something a little more complex. Because it also is, we're being greedy where we're just changing. I'm just changing the first instance of the character, but I need something a little more intelligent because it might be, you know, the spacing around, not the spacing, but like the distance any one character has to like another one of the opposite type, if that makes any sense. Yeah, because here, 1, 0, 1, 0, output 5, expected 3, to make them all alternating. Well, if we took this one, start at 1 here, these are not the same, so it's fine. These are the same, so change this to 1. So that gives us 1. These are the same, so change that to 0. That's 2. These are the same, so change that to 1. Right? And then these are the same, so change that to 0. Then these are the 1. Exactly. So that's actually, that is going to be 5. Tricky, tricky, tricky. 1011 0100. The minimum amount. Yeah, I'm definitely stuck on this one. 1011 Is there another way to do this that's like not greedy? Well, you know what this means. If you guys have seen a lot of my streams before, you know that at this point, and when I say at this point, what is it that I mean? So for the first portion of all these videos, my main goal is to try and get as close to 591 questions, which is crazy. Like, we're not even, I mean, we're almost halfway, but you know, it's been a long journey. But interestingly enough, we're already on page 4. And I don't, wait, is there more than, yeah, there's not even more than 5 pages. So we're on the second to last page. What's going to happen is we're going to get through all these questions, and then through weekly roundups, and probably at the end, what I'm thinking, when we're at question 500 or question 540 or something, I'm going to have longer streams of me like really, really trying questions out. And it might get to the point where like we only do a single question for a whole stream, but we're just going to be like really, really pushing through it before we finally get to the medium style question. So because of that, and because I'm focused more on quantity right now, let's go ahead to the second one and do most visited sector in a circular track here. All right, so I remember, oh man, if there's anyone from the Discord, we did a code race for this one a long time ago. I think it was a code race, or maybe it was just a random question we all came up across. This one's strange. Given an integer n, and you know what? Oh man, is this a bad reason to cop out? I already have like prior knowledge of this question, so I don't want to like, I wasn't able to solve it then, so I don't want to spend time knowing that I might get stuck and not be able to present another question that might be more valuable to people watching. So I'm going to go to this one, relative ranks. All right, cool. You're given an integer array score of size n, where score of I is the score of the ith athlete in a competition. All the scores are guaranteed to be unique. The athletes are placed based on their scores, where the first place athlete has the highest score, second place athlete has the second highest score, and so on. Placement of each athlete determines their rank: gold medal, silver, bronze. For the fourth place to the nth place, their rank is their placement number, i.e. the x place rank is the x number. So 5, 4, 3, 2, 1. Gold medal, silver medal, bronze medal, 4 and 5. So here, I think what we can do is if we like sort this, where we have 3, 4, 8, 9, 10, we know that 3, 4, and 8 are gold, silver, and bronze respectively. So we can save that. Yeah, so here's what I'm going to do. I'm going to sort the input. So let's say const sorted scores is equal to score.sort a, b, a minus b. And then what we'll do here, now with the sorted scores, what is it that we want to do? I think I should say it's 1, 2, 3, the first place. Yeah, I think what we can do is I can say const ranks. We'll set this equal to an empty array. I'm sorry, not an empty array, an object literal. And here I can say for let I equals 0, I less than sorted scores dot length, I plus plus. So let's see. Here I can say if I mean, we could do, I think I could do like a switch case in here. Yeah, here I can say switch on I plus 1, and the case will be for 1. So if we're 1, then we can say ranks of I guess I plus 1. Let's say position. Let's say const rank equals I plus 1. Here I can do a switch on the rank. And I'll say ranks of rank is equal to gold metal, gold meal. And then we'll break. Here we'll do case 2. Keep doing this. Oh, did not want to do that. It's going to put it way over there. Ranks at ranks is equal to silver metal. And case 3, ranks of rank is equal to bronze metal. And the default for everything else, we'll just do ranks of rank is equal to, we can just do string of rank, right? Break. And now I think once we get all the ranks, what we can do is we can return score. And if I want the index, yeah, I think we can return score. Got to think about this. We can return score dot map where we get, I want to get S and I want to get the index. And what I'm going to return here is ranks. Let's see. Do I need the index? Case of 1. Rank of rank. Maybe I don't want, maybe it's not rank of rank what I need, because I actually need, what is it that I want here? I want 3 to be the first one, and this one should have gold medal. How can I also, how can I take, yeah, I think I might want to do this a different way. 3 should be gold medal, 4 silver, and then everything else should be just lined up. Now, how can we say 5? Let's see, 5 is going to be like, well, let's go to this example. When I go to 10, I'm going to see 10 as 0, 1, 2, 3, 4. And I'll just put that for 10. 10 will be 4. 3 will be gold medal. I mean, I could create, maybe what we need to do is actually say const ranks. Here we can do gold medal, silver medal, and bronze medal. We have sorted scores. Okay. Let's see. I'm still going to keep this right here. But as long as my I is less than ranks, so if I is less than ranks.length, maybe this should be medals, and I guess, well, I think I still do need ranks, right? I still do need ranks. If I is less than ranks.length, then I can say ranks at sorted scores of I, which is going to give me 3, right? Sorted scores of I equals 0, 3 is going to be equal to medals of I. Else ranks of sorted scores of I will just be equal to string of I. And now at the end, we shouldn't even need this anymore. We can just get the value and say ranks of S. Let's see if this works. 4, 3, 2, 1, 0. Okay, I feel like medals of I. So let I equal 0, I less than sorted scores, which is this one. If 0 is less than medals.length, that's where I went wrong there. Let's also remove this here. Four, 3, bronze medal, silver medal, gold medal. Oh, am I? Score.map ranks of S. We have sorted scores. 4, 3, bronze medal, silver medal. Interesting. Let's come back here. I know we're close. 1, 2, 3, 4, 5. We have our medals. Gold medal, right? Because 0 is gold, silver, bronze. All right, for let I equals 0, I less than sorted scores dot length. Let's expand our ranks to see what we should get. So if 0 is less than medals dot length, so the ranks of sorted scores of 0 is 1, is going to be equal to medals of 0, which is gold medal, right? Gold medals of I. Okay, so we do I plus plus. I is still less than medals dot length. So we can say ranks of sorted scores of 1, 2 is equal to silver medal. 3, so 0, 1, 2, which is 3, is going to be equal to bronze medal. Else, ranks of sorted scores of I, which is now 3, or is equal to 4. Yeah, well, index 3 is equal to 4. That's just going to be equal to 4. Okay, so then we go to score. Does it not like that we, let me see, sorted score, we return score.map of S. So now score.map should be 5, 4, 3, 2, 1. Oh, but it expected gold medal, silver medal, bronze medal. Does it not like the placements are first, second, third, fourth, and fifth? This is so strange. Oh, the highest score. Wait a second. That makes sense, right? Let's reset this. Is it because I was sorting based on the lowest? Could very well be that. Three, 4. So should this also be rank of S? Should this be I plus 1? Maybe we should always set, we can set this, but ranks of sorted scores of I. So we're off by 1, but where? Sorted scores of I is 0. But then maybe if we're just outputting this, should it just be I plus 1? Let's make sure, because that seems strange to do it for just that one. 4, 5, 5. Okay, let's submit it. Okay, a lot of different things happening here, but the bottleneck of this is going to be the sort, right? Because that's going to take n log n time. Whereas this one right here is just going through sorted scores once. So it's n log n plus n. The bottleneck is n log n. And our space-time complexity here is going to be n, because there can be, like, ranks can grow to be, well, I guess it'll be n minus, no, actually, no, it'll be n. It'll be however many different scores there are. There will also be ranks. So it's n log n with n space. But I can't help but think there could be a better way of approaching this. So let's see what we got. Can we get like a hint? Easy Java solution sorting. Well, okay, there we go. If these are like the highest voted answers, especially from someone that is this highly ranked in rep, that's awesome. Yeah, very similar to what we did here. Space complexity is still O of n. All right, very nice. We're approaching the end of the stream for today, but wow, Roman to integer is here. That's crazy. There's still so many like of the questions that you see in top 100 interview questions that we haven't gotten to yet, which is mind-boggling. Like, I don't know, have we done reverse linked list? Maybe we have, but like Roman to integer, that, yeah, that's crazy. We haven't gotten to that. Convert 1D array into 2D array. Haven't we tried this one before on stream? M equals 2, n equals 2. The constructed 2D array should contain 2 rows and 2 columns. The first group of n equals 2 elements in original. 1, 2 becomes the first row. This doesn't seem like something that we can solve in 3 minutes, and I also don't want to be... The reason I like to stick to 3 minutes or 1 hour is because I want to have some consistency. Like when people watch the stream, they should know that, oh, I only have to watch for an hour, right? I don't want people to think, well, oh, today's 2 hours, another day is 30 minutes, another day. I mean, there will always be some exceptions, but if I can try and get as close to that time as possible, then I think we're good. I think it'll be good for us to maybe end it here, and then tomorrow, well, tomorrow's going to be our weekly roundup, so we'll actually start from the beginning and look at some other questions we haven't gotten to. But then on Monday, we can start off with like Roman to integer or monotonic array. A lot of these are like really great questions. I haven't seen any of these in a while. All right, cool. Yeah. So yeah, very happy with today's stream. Hopefully all you guys found it informational and fun. And remember, this sort of thing is like more like these streams are intended to be very like podcast style, long form. So if you just want to like kick back, relax, hear me talk about LeetCode, this is the stream for you. I've since started creating other content that revolves more around like tailored videos, because I do realize that some people want to just watch a single video with a very focused question. So that's what I'm going to start doing with a lot of the explore cards on LeetCode. And I guess just as a little teaser, perhaps, recently I've been thinking about maybe starting an actual LeetCode podcast where I can have people with very high reputation or many years of experience, or like the most contests won, have them on the stream and have them talk about their LeetCode experience and just go from there. I think it could be kind of something cool to offer. So stay tuned for that. Might be seeing something like that in the future. So anyway, thank you all so much for joining. Really appreciate having you all here. Have a great night.